Good morning, guys. Welcome to the library of Tarvalon. This day, we are going to learn about complex numbers by simplifying them or evaluating them or even sketching them. So, we have 4 examples for today and let us proceed. Number 1 example. We have 3 minus j2 times 1 plus j4 all over 2 minus j3 times 4 plus j. First, we have multiplied the numerator. 3 times 1 is 3. 3 times j4, that is j12. Negative j2 times 1 is minus j2. And negative j2 times positive j4, that is positive 8. To the denominator, 2 times 4 is 8. 2 times j is j2. Negative j3 times 4 is negative j12. Negative j3 times j, that is positive 3. Then, combining similar terms, we have 11 minus plus j10 over 11 minus j10. Getting the conjugate of the denominator, to simplify further, we have 11 plus j10. Multiplying both fractions, we have 121 plus j110 plus j110. And since similar signs of j, that is minus 100 all over 11 plus 100, or rather 121 plus 100. Combining similar terms, we have 121 minus 121 plus j210 all over 221. This is equal to 21 over 221 plus j 210 all over 221. And getting the decimal value, that is 0.095 plus j 0.995, and that is how we solve it. So, it's not so hard, right? To proceed with the second example, we have simplifying j raised to 561 minus j raised to 174. I will use j raised to 4 since j raised to 4 is equal to 1, and 561 divided by 4, that is 140, and the remaining 1 will be used by multiplying j, then minus another j4, and 174 divided by 4, that is 43, and the remaining 2, that will be j2. Then j4 is equal to 1 times j minus j4 is equal to 1 times j squared is equal to negative 1, then equals to j times 1, that is j, minus negative 1 times 1, that is negative 1, j minus negative 1, that is j plus 1. So, let's proceed to the next example, which involves evaluating complex numbers. So we have the given, evaluate 2 minus j 2 square root of 3 raised to the 6th power. First, we get the r, which is equal to the Pythagorean theorem square root of x squared plus y squared. This results to r equals 4. Then, in getting the angle is equals to the arctan of y over x equals to the arctan of negative 2 square root of 3 over the x, which is 2. So the angle is negative 60 degrees. So our polar form for the given is 4 to the angle of negative 60 degrees raised to the 6th power. Then our r, which is 4, will be raised to the 6th power, while the angle, which is negative 60, will be multiplied by 6. This results to 4096 as our magnitude and an angle of negative 360 degrees. In rectangular form, that is simply 4096. So, on to our last example. We have sketch and find the fourth root of the given. Negative 4 square root of 3 plus j 4. First, we get the r. Since the fourth root is equal to the raise to the power of 1 over 4, we first get the r by using the Pythagorean theorem. The x with a value of negative 4 square root of 3 and y with a value of 4, which results to r equals to 8, and an angle with arctan 4 over negative 4 square root of 3. We get negative 30 degrees. So z in polar form is now equal to 8 with an angle of negative 30 degrees raised to the power of 1/4. That is equal to 8 raised to 1/4 and an angle multiplied to negative 30 degrees multiplied to 1/4 equals to z with 1.68 with an angle of negative 7.5. Turning the polar form into the rectangular form, we should get first the x and y values by using the formula r cosine the angle and r sine the angle. Using a calculator, we get the value of x by 1.68 cosine negative 7.5, and its value is 1.67 with an imaginary number of 1.68 sine negative 7.5 equals to minus j 0.22. Now sketching, first we draw the diagram and label the real and imaginary numbers. The real is the x-axis and the y is the imaginary number. So we trace both numbers and we draw the z with an angle of negative 30 degrees. So that ends our lecture for today. The things that I have learned for today's lecture are the imaginary number, the properties of complex numbers, its operations, and sketching the complex number in an argon diagram. And lastly, converting the complex number from polar to rectangular form and vice versa. Thank you for watching and see you next time.